Hello guys, welcome back. Today I want us to look at some random question from electrochemistry. You remember we said our series will be tackling questions from each and every topic so that to enhance learners with knowledge and skills they need for them to tackle their examinations. So today I want us to look at a question from electrochemistry and see how learners are supposed to answer the questions. To start us off, we have a question here. The setup below was used in electrolysis of copper 2 chloride solution. So this is aqueous copper 2 chloride solution. So from this question, this is copper 2 chloride. So the ions present in copper 2 chloride, we have copper 2 ions. Start with the positive ions, copper 2 ions and hydrogen ions. Copper 2 ions and hydrogen ions being the only positive ions, because this is aqueous copper 2 chloride, meaning it contains water. And then also the negative ions, we have the hydroxide ions and also the chloride ions. The hydroxide ions and also the chloride ions. So from there we can be able to interpret the question. So which ions are going to be preferentially discharged? Remember, for ions to be preferentially discharged, we look at the three factors. Number one factor is the factor of position in electrochemical series. Position in electrochemical series, and that normally affects the positive ions. It affects the positive ions, and remember the positive ions are migrating to the cathode and also the negative ions migrating to the anode. So mostly the position in the electrochemical series affects the reactions at the cathode. So, and also if you look at these two, two cations, the copper 2 ions and hydrogen ions, if you look at the position in their positions in the electrochemical series, you realize that now copper 2 ions are below hydrogen ions in the electrochemical series. So copper 2 ions are going to be preferentially discharged and not hydrogen ions. So we are going to have the copper 2 ions being discharged at the So at the cathode we are going to have copper metal being deposited there, because copper is below hydrogen in the copper 2 ions are below hydrogen in the electrochemical series. Number 2 is the factor of concentration. So the factor of concentration will only affect the ions at the anode. That is to say, to be more specific, we only look at the ions which are the halides. Halides, in other words, the halogen. The factor of concentration will only affect the halogens, and halogens are going to be preferentially discharged if they are of higher concentration, or if they are more concentrated, or if they are concentrated. For this case, this is aqueous copper 2 chloride. Remember, chlorine is an halide, but now because of the factor of concentration, they are dilute, so meaning they are never going to be discharged. So when they are dilute, we just also look at the position at the electrochemical series, so meaning the OH ions are going to be discharged, meaning at the anode we are going to have the oxygen gas being produced. So we have the 4 OH ions losing electrons to give us 1 mole of oxygen gas plus 2 moles of water plus 4 electrons. So meaning now at the anode we are going to have the oxygen gas being produced, and at the cathode we are going to have the copper metal being deposited there. So from From the setup, you can be able to tell which one is the anode and which one is the cathode. The anode, we are saying the colorless gas, which is oxygen. Now this gas P is oxygen. Oxygen is going to be given, gold is going to be produced, and at the anode, at the cathode, we are going to have the copper. So this side, this is where we are going to have copper. So this is the cathode, and also this electrode, this is the anode. That is the anode. And also number three factor is type of electrode. Type of electrode, where we have two types of electrodes. We have the inert electrodes. The inert electrodes are the likes of platinum and also graphite electrodes. Those ones, they do not affect the ions to be preferentially discharged. And then we have the active electrodes. Like now, if this is copper 2 chloride solution and using copper as the electrodes, those ones, they affect the ions to be preferentially discharged. The ions we have seen, we have copper 2 ions, hydrogen ions, hydroxide ions, and chloride ions. When we are using the active electrodes, these ions will never be discharged. Instead, what is going to happen, the anode is going to dissolve into solution, and also the cathode is going to be reduced. So we say oxidation will take place at the anode and reduction will take place at the cathode. So what the change in mass, now what's going to be observed is the electrode which is at the anode will be eaten away or wears out as the atoms surrounding the solution will dissolve into solution, and at the cathode, some of those ions will be reduced to the copper metal. So those are the three factors to take into consideration for the ions to be preferentially discharged. But we tell learners, whenever you have silver ions, copper 2 ions or mercury ions against hydrogen ions, these ions will always be discharged because they are below hydrogen in the electrochemical series. Other ions like magnesium, potassium, sodium, they are never easily discharged. So that is it. Now let's go to the questions. What is electrolysis? What is electrolysis? From the knowledge we have of electrolysis from Form 2, Form 4, we can say it is the decomposition. It is the decomposition of an electrolyte by passing an electric current through it. So you are decomposing an electrolyte by passing an electric current through it. So label the anode and the cathode on the diagram. We have already labeled the anode and the cathode. This is the anode where oxygen gas is going to be produced, and this is the cathode where we are going to have copper 2 ions being reduced to copper metal. Explain how you would confirm gas P. Now that we have said gas P is oxygen gas, we can introduce a glowing sprint to the gas where we introduce a glowing sprint to the gas, it's going to relight. So it relights the glowing sprint. That is the confirmatory test of oxygen gas. Use the standard electrode potentials given below to answer the questions that follow. You have been given the half reaction and the EMF. So you've been given the one of zinc and their EMFs there. So identify the strongest reducing agent. We say the strongest reducing agent is the one which is always the more negative. So the more negative is the strongest reducing agent, and that is, for that case, I can see it is zinc because it has negative 0.76, negative 0.13, positive 0.80, and also positive 0.34 for copper. So the more negative is zinc, so meaning zinc is the strongest reducing agent. It is the strongest reducing agent among these four metals. We mean that zinc is the most reactive metal compared to copper, silver, and lead. So it is the strongest reducing agent. It will reduce all these other metal ions into their corresponding metals. Choose a pair that will form a cell with the least EMF value. So for that one, you have to draw this numbering. So you have a negative towards this side is negative 0.13, negative 0.76, positive 0.34, and also positive 0.80. Remember now, the one which is going to give you the least EMFs must be those ones which are close to each other. Like now 0.34 and 0.8, you find the difference. This is 0.46, 0.34 negative that one, 0.13 will give you 0.47, and this one will give you 0. That one is 3, that one 6, 3. So the least, the pair which will give you the least EMF will be that one of silver and copper. And because this is the cell you are being required, the cell representation, you just write silver ions plus an electron to give us silver, and copper 2 ions plus 2 electrons to give us copper. That one will give you, that is the pair that will give you the least EMF. Calculate the EMF of that cell above. So E cell equals to E reduction minus E oxidation. E reduction minus E oxidation. So, or E right hand side minus E left hand side. What we mean here, we always assume that cell which undergoes reduction is always on the right hand side, and the one which undergoes oxidation, it is on the left hand side when we are drawing an electrochemical cell. So that is 0.80 minus 0.34, which is positive 0.46 volts. Positive 0.46 volts. Remember, lazima uweke hiyo sign. You write the cell notation represented by the above information. We have seen, so you start with the species which undergoes oxidation, that is copper 2 ions, and then you have 2 silver ions to give, undergoing reduction to give us 2 silver atoms. So you have to write the state symbols. This is solid, aqueous, solid, and then you have now to write the EMF of that one. E equals to positive 0.46 volts. That one you could have written the cell notation. Draw a well-labeled diagram to show how impure copper can be purified. So this is where I want learners to take keener interest and listen. So whenever you've been told that one, many times learners are fail to distinguish between an electrochemical cell and also an electrolytic cell. Those are two different things. But many times learners fail to distinguish between an electrochemical cell and also an electrolytic cell. Remember, for an electrolytic cell, we are only having, okay, let's say if this is the beaker, we are only having one beaker. We don't have things like salt bridge. We don't have, so draw a well-labeled diagram to show how impure copper can be purified. Some things which learners need to know. Number one, always the impure metal, let's say metal, is on the anode, or the impure metal is the anode. The pure is the cathode. So when we are drawing, for example, if this is our impure copper like that, so the impure copper is going to be the anode, meaning it's being connected to the positive terminal of that cell or the battery, and then the pure one is the cathode. The pure one is the cathode. So you have to show the battery, so that is the battery. You have to show the, and now this solution must have, the solution has to have the ions of that metal which is supposed to be purified. And for that case, we are saying this one is copper 2 ions. Copper 2 ions, or it can be a solution of any copper, so can be copper 2 nitrate, copper 2 sulfate, or copper 2 chloride, like that, which is in aqueous. So this is impure copper, and then down here it will form a sludge. It will form a sludge, and then this is pure copper. So with this drawing, then at least you can be able to gain some 2 marks. So what it means here, so this impure copper will dissolve into solution, thus shading those impurities as in, and they will be settled at the bottom as sludge. And also now the pure copper, more of the copper 2 ions will be reduced at the cathode to form a pure copper. And also another thing learners need to know from this setup is also electroplating. When we are doing electroplating, so the method to be electroplated, remember we said that we have two reasons as to why we are electroplating substances. Number one is to make them look attractive. Like now, if I have a silver spoon, I want it to electroplate with maybe gold to make it look attractive. And also number two is the factor that to prevent them from corrosion or rusting, like now in the case of iron. So the method to be electroplated, it is always on the cathode. The method to be electroplated is always in the cathode, and the method to be used in electroplating that method should be on the anode. I don't know if we are understanding each other. So in electroplating, we are saying the method to be electroplated should be on the cathode. For example, if this is the setup, let me sketch a setup here. If this is my iron spoon, which needs to be electroplated, it has to be on the cathode. So, and then the one to be used in electroplating, let's say zinc, or silver Ag has to be on the anode. And the solution must have the ions, of the metal used in electroplating. So if you are using silver ions if you are using silver to electroplate an iron spoon, then we are going to use a solution of silver ions. Think with that, if learners can understand that one, then we can be able to move in the right way. Another question here we are on. This is a paper 2 question. It says 1.21 gram of a metal P were deposited when a current of 2.20 amperes was passed through a molten salt of R for 30 minutes. You have been given the RAM of P to be 65 and 1 Faraday is equals to 96,500 coulombs. So calculate the quantity of charge in coulombs used to deposit 1.21 grams of the metal P. We know we have the formula which says M equals to Q, where Q is the quantity of it, times RAM, you divide by N times F. RAM, that is the RAM of the metal. For that case, you have been given 65. N is the charge and F is the Faraday, and also M is the mass which is being deposited. So we have 1.21 be given which is equals to Q. You have to calculate Q. Quantity of charge is given by IT. I is 2 times T must be in seconds, 30 times 60. 30 times 60, that is 1800 times 2, that is 3600. And then RAM, that's 600 coulombs times RAM, which is 65, divided by N times 96,500, where you get equals to 2. That one will be 2. So if you deduce the charge, because that is a metal, it's going to be 2 plus 2 plus 2, P2 positive, like that. Thank you. That was a question from electrochemistry. We have discussed about the electrode potentials. We have discussed about the electrolysis and also the factors to take into consideration for the ions to be preferentially discharged. If you feel free, if learners have still problems in identifying the ions to be preferentially discharged, if they want me to make some comparisons, and also those ones who are stuck in the oxidation numbers, calculating oxidation numbers and the drawing of the electrochemical cells, let them be free and write down in the comment section what we are supposed to cover. That is it for today. Bye bye. We meet next time.